In this video, I'd like to talk about finding the area of composite shapes. So the first question we should have is, what is a composite shape? And composite shapes are essentially composed of smaller basic shapes. So we have this shape right here that we need to find the area of, and we're told it has two pairs of parallel sides. So this side here and this side here, these are going to be parallel, and this side, these will be parallel as well. And what you can notice is that this larger shape is composed of several smaller shapes. So if we drew a line right here at a right angle, then we have this top shape that is a square. And if we also draw a right angle line vertically up here, then we also have a rectangle here. This would also be at a right angle. And this would be a triangle. So this shape, this composite shape, is composed of a square, a rectangle, and a triangle. And generally, there are two different strategies we can use to approach this type of problem and actually find the area. The first strategy is to break this down into smaller shapes and then find the area of each. So we can find the area of this square, we can find the area of the rectangle, and we can find the area of the triangle and then just add those together to get the total area. Or we can notice that this entire shape is really just a rectangle with some bottom triangle taken out of it. So we can find the area of this rectangle and then just subtract the area of this missing triangle. So either strategy works, and we can use both of them in this video to check to make sure that we're on the right path. So let's start by just finding the area of each of these smaller shapes. So we can find the area of this square first, and the area of a square, or rectangle in general, is just the length multiplied by the width. So we can say the area of A, that top square, that is just 4 times 4, which is 16. Then we can look at the area of the rectangle, which again, we're going to use the same formula. So we want to find the area of B, and that would be, well, it has a width of 2. And notice that since this is a length of 4, and then we went over at a right angle, it split this side into two pieces where this is 4, and we know the total length is 8. So that means this has to be 4. So this rectangle has a width of 2 and a length of 4, so its total area would be 8. And then likewise, we need to find the area of C, this triangle here. And we know this has a base of 4. Let me use a darker color for that. So the base of this triangle is 4. Since we know the area of a triangle, remember, is the base times by the height, whatever this is, multiplied by 1/2. And since this length is 2, and we drew this line vertically up at a right angle, and if you want, you can even continue this. So let me draw it the entire way. So something probably closer to that. I didn't draw it perfectly the first time. But this would now be at a right angle. And it would split this into two different pieces, where we know this is length 2, and they have to add up to 4, so this is also length 2, which means that this piece right here is length 2. So we have this triangle where the base of it is 4, and we can mark that the height is 2. And so again, the area of a triangle is half the base times by the height. So the area of C would be 1/2 of 4 multiplied by 2. So half of 2 is 1, and 4 times 1 is 4. So we can say the total area then is just the sum of all three of these small areas. So it's A plus B plus C, and we know A is 16, B is 8, and C is 4. So 16 plus 8, that's 24, plus 4 more is 28, and we don't have units, but we can say this is 28 square units. Now, again, if we want to check this, we can use the other approach where we can notice that this is essentially a rectangle with a missing triangle. So let me draw in the rectangle here with the right tool. And we just need to find the area of the rectangle and subtract off the area of the triangle. So let's say we want the area of the outer rectangle, or just I'll refer to it as the rectangle. And the area of the rectangle is just the width times by the length. So our width is 4, our length is 8, so we get 4 times 8, which is 32. And we want to subtract the area of the triangle. So that is this triangle that's missing here. So the area, we can say, of the missing triangle is just equal to, well, it's half the base times the height. So we need to find the base and the height. And we know this is 4 since the total side length has to be 8 when we compare it to the opposite side. And we know this total length has to be 4 because of comparing it to the opposite side. So that means this has to be 2. And again, this will be at a right angle since this is a rectangle. So we get half the base, which we can call 4, multiplied by the height of 2. And half of 4 is 2, times 2 gives us 4. So when we find the area of our composite shape, we take the area of the rectangle and subtract the area of the missing triangle. So this total area right here, we could have looked at a different way. That is the area of that rectangle right there minus the area of the missing triangle, which is 4. And so we also get 28 square units. So both ways will produce the exact same answer, and they're both valid strategies for approaching these composite figures and how to find their area. So you want to determine by yourself with experience which way would be the better approach.